What is going on, everyone? Binary Tech Labs back again. And today we're going to talk about electrical code requirements, specifically Canadian Electrical Code 12-3034 for devices like the Shelly 1 and Sonoff Mini R2. But initially, you may be asking yourself, who am I to speak to these requirements? To answer your question, I am a Red Seal construction electrician, as determined by the authority having jurisdiction in my area. This video's content is only for educational purposes. I accept no responsibility for what you do with the information. I am not liable for any property or medical damages resulting from what you see in this video. For any job involving electricity, especially mains voltage, always check with your authority having jurisdiction, local electrical codes, and certified electrical contractors. Today, we're going to cover the following topics: Shelly and Sonoff devices, electrical safety certifications, Canadian Electrical Code, calculations, and permit or no permit. If this seems interesting to you, stick around and let's get started. Looking to add smarts to your lights or plugs, but don't want to replace them? Well, you've probably come across these two major companies offering these solutions. They are Shelly and Sonoff. So let's start with who these companies are. Shelly is one of the world's fastest growing IoT brands offering solutions for smart home and building automation. And Sonoff is a top-ranking smart home automation manufacturer specializing in research and development, design, and production. In both cases, they can be used as a standalone device, as an auxiliary to a home automation controller, or as a component of another automation system, like Home Assistant. You have the ability to operate a wide range of home and office items like lights, plugs, garage doors, curtains, security systems, heating systems, air conditioners, just to name a few. Sonoff currently has a somewhat broader product selection, but Shelly is swiftly catching up. Sonoff devices all have CE marks, which are meant for the European market, which does not imply certification for usage in Canada. Conversely, Shelly has some of their devices tested to UL standards with certificates in both Canada and the United States. So for me, the Sonoffs are a non-starter, as I will not risk my license. So let's talk about these electrical safety certifications. There is a common misconception that a product that has a CSA group or UL listed marks, both with C and US subscripts, allow you to install these devices anywhere, when in fact, these labels just indicate that the individual devices have been tested to the same harmonized Canadian Electrical Code, CEC for short, and National Electrical Code, NEC for short, criteria, implying that if correctly wired, they should not start a fire. But to be clear, there is no guarantee that a certified device would not start a fire, or that a non-certified device is dangerous just because it lacks certification. If there is ever a doubt, both CSA and UL have identifying information or a control number that can be used to look up the product in their respective databases. And if you look at Shelly's certificate of compliance, the Shelly 1, Shelly 1 PM, and Shelly 2.5 have all been tested under UL and meet this standard. But not all things are equal. There is a lot of old stock out there, and just because these new devices now meet this standard doesn't mean that they all do. So how can you tell the difference? All devices that have certification are required to publish or label the product as such. So, if your product does not have the UL mark, it is not certified. And that comes from the authority having jurisdiction in my area, as well as from Shelly's own certificate of compliance, which you can see here. Regardless of certificate, when installing these devices, you must still adhere to all electrical codes if you want them to pass inspections. So, for now, we will ignore the certifications for this video and just go through the electrical code requirements to see whether in fact we can install these devices in our house. Okay, as I mentioned, we're going to be looking at the Canadian Electrical Code, Section 12, Rule 3034, which regulates the maximum number of conductors in a box. Looking at the rule, it is intended to guarantee that electrical boxes are of sufficient size to provide usable space for all insulated conductors contained within the box, meaning that the box is correctly sized to allow for effective heat dissipation, which is critical to this rule. I'll use two of the most frequent examples that come to mind: a light switch and an electrical outlet, also known as a plug, with the exception of kitchen outlets, as most are now 20 amps. Your residential wiring will be 14 gauge in size. We will also only consider a single gang device box rather than multi-gang boxes, which include more than one electrical device. Also, because Sonoff is a no-go for me, I will not be looking at these devices. But I do like them, so if anyone from Sonoff who happens to view this video, please get certified. I would love to use your products in my home. Here we can see the normal wiring for the two devices we'll be discussing, as well as how to connect the Shelly to control the devices. If you want to control the entire plug, leave the tab on the side in place. If you simply want to switch the top or the bottom of the plug, break the tiny tab on the line side of the plug and connect another power wire to the one you want on all the time. So now let's have a look at code rule 12-3034. I know it looks a little complicated, or maybe it's overwhelming, but let's break it down. Looking at subparagraph 1, we can see that there are 4 sections to the rule. But right off, we can eliminate subparagraphs 1a, 1c, and 1d, as they are irrelevant to this example. However, subparagraph 1b states that each conductor entering or exiting the box and attached to a terminal or connector counts as one conductor. So in the plug example, we have 2 wires coming in and 2 wires going out. So we'll have to add 4 conductors. And for the switch, we also have 2 wires coming in and 2 wires going out, so we'll add 4 conductors as well. Now let's see subparagraph 2. Here it's further broken down into 3 parts, and subparagraph 2a doesn't apply. Subparagraph 2b indicates that every 2 morettes must be counted as one conductor. And finally, subparagraph 2c indicates that we must count 2 conductors for every flush mount item, such as a plug or switch. However, if the switch has numerous switches and is all mounted on the same strap, it only counts as 2 conductors. So what that means is just you might have seen switches that have 2 or 3 switches and it's all on one device. That would still only count as 2 conductors. So in the plug example, because the Shelly is not designed to retain more than 1 wire beneath the terminal, we must utilize 2 morettes. So we'll have to add 3 conductors, 2 for the plug and 1 for the morette. And in the light switch example, same as the plug, we're going to have to add 3 conductors, 2 for the switch and 1 for the morettes. Now let's take a look at subparagraph 3 of the rule. It reads, where a box contains a device having a dimension greater than 2.54 centimeters between the mounting strap and the back of the device, the total usable space shall be reduced by the space occupied by the device, calculated as 82 cubic centimeters multiplied by the depth of the device in centimeters divided by 2.54. So in the plug and switch examples, the Shelly 1 has a depth of 1.7 centimeters and would occupy a space of approximately 55 cubic centimeters. That is 82 times 1.7 divided by 2.54. So when the rule talks about a device having a dimension greater than 2.54 centimeters between the mounting strap and the back of the device, usually they're referring to GFCI plugs. But in this case, and I did confirm with the authority having jurisdiction in my area, a local code inspector, and this is the rule that we would apply to the Shelly being put behind the plug or the switch in order to get the proper box fill calculation. So now let's look at subparagraph 4. Subparagraph 4 informs us that we may calculate the usable capacity of our device box using table 23. There are other possibilities in this table, but we'll go with the most commonly installed one. It's a single gang device box with dimensions of 3 inch by 2 inch by 2.5 inch, which has a capacity of 204 cubic centimeters. This is critical for our calculation. Subparagraph 5 is going to refer us to table 22, and this is where we can find the volume for each conductor. And in that table, it specifies that 14 gauge wire has a volume of 24.6 cubic centimeters. Subparagraph 6 refers us to multi-gang device boxes. However, as I've already stated, we're not going to be discussing these here. And that's the whole rule for 12-3034. Okay, I realize that was a bit dry, but if you sat through it all, kudos to you. You deserve a medal. So let's put it all together and see whether these devices can actually be deployed where we want them. Looking at the plug and switch examples, just to summarize, subrule 1 and 2 gave us 4 plus 3 conductors, giving us a total of 7 conductors. Table 22 gave us 24.6 cubic centimeters for 14 gauge wire, which totals 172.2 cubic centimeters for our 7 conductors. The Shelly takes up 55 cubic centimeters according to subrule 3 for a grand total of 227.2 cubic centimeters. Well, table 23 provided us a total of 204 cubic centimeters for a typical device box that is installed in most homes. So it appears that in both cases, we can install the Shelly inside the device box. It would have to be a minimum of a 3-inch by 2-inch by 3-inch device box, which would give us 245 cubic centimeters. Now, this won't always be the case because some plugs at the end of the run will only have one wire coming into it, so it would meet code requirements in this case. But for the rest, we would have to replace the device box for the larger one. But who cares about code rules and permits in the first place? I'm sure I'll never get caught, right? Well, electrical work permits are required to safeguard the safety of people and property. I know the permitting process may be inconvenient or time-consuming, but it is necessary. And if you decide to perform unpermitted work or ignore code rules, keep the following factors in mind. If you ever want to refinance your home, you'll need an appraiser to evaluate it for you. So, unpermitted modifications may prevent you from refinancing your house. Homeowner's insurance is another one. If a fire is determined to be caused by unpermitted modifications, the insurance company may refuse the claim. Even if you get away with not acquiring a permit once or twice, you're likely to run into an issue sooner or later. So to summarize, performing electrical work without a permit can result in penalties or fines. Worse, a single spark could change your life forever. And take it from me, as someone that has lost everything because of a fire that happened when I was younger, you don't want to go through this. So simply put, it's just not worth the risk. Always acquire a permit and utilize approved equipment in your home. And I don't know about you, but I couldn't afford to pay for my home rebuild out of pocket if the insurance was void, and I certainly couldn't live with myself if I caused harm to another human being. As I am sure you've heard countless times, play safe around electricity. Okay, if you've made it this far in the video, I really appreciate you. I hope you discovered something useful today. I'd love to hear your questions, thoughts, or concerns in the comment section below, and I hope to see you in future videos. Goodbye.